This is section 4.2, part B. So we've looked at adding and subtracting our rational expressions. We now want to look at adding and subtracting. We did the multiplying and dividing already. So, to add or subtract numerical fractions, you probably remember that the key is to having a common denominator. I need a common denominator, whether I've got numerical fractions or algebraic fractions. And if I do, I can simply add or subtract the numerators. So 7/9 minus 4/9, I subtract the numerators and get 3, keeping the common denominator of 9. And then, of course, I want to see if that reduces, and in this case it does. So my final answer is 1/3. I have that same sort of process with algebraic fractions. I do need to be a little bit careful, however. Remember that when you're subtracting this fraction, great, I've got a common denominator, but that minus sign applies to both of these terms. I often recommend to people that they take just a moment and do a quick rewrite. Change that to plus, and then distribute the negative through the numerator. It just avoids a lot of mistakes, and it only takes a couple of seconds. All right, I can now combine my like terms. So I'd have 1x minus 2. And I still have my common denominator. I should check to see whether that's in lowest terms. And in order to do that, I would need the factored form of the denominator. I can see that's a trinomial with a leading coefficient of 1. So I'll just start out with x times x. And then looking for a sum of -6 and a product of 8. I think a -2 and -4 are going to do that. Doesn't hurt to throw some parentheses on there just to make it look a little better, because I can now see that I can divide out those x minus 2's. Those divide to 1. So my final answer in lowest terms is going to be 1/x minus 4. This comes up a lot with subtraction, so again, if it helps you to not make errors with the signs, I really recommend taking a moment to write that out when you have a subtraction problem. All right, so what happens if we don't have common denominators? Well, if we don't have them, we have to get them. So if I look at something like 5/6 and 3/4, I start by saying, what's my lowest common multiple or my least common denominator? For 6 and 4, 12 is the smallest number. That's a multiple of both of those. So I'm going to start with my 5/6, and I'm going to say I have to turn that 6 into a 12. To do that, I'll multiply by 2. And notice that I always multiply by a form of 1. So if I multiply by 2 on the bottom, I have to also multiply 2 on the top, so that I'm really multiplying by a form of 1, which doesn't change the value. It'll change the appearance of my number, but not its value. I have to think similarly with the 3/4. I have to think, how am I going to turn that 4 into 12? I need to multiply by 3, but that has to be a form of 1, so I'll actually multiply by 3/3. I've now got 10/12 plus 9/12, or 19/12. That's done. This is already in lowest terms. There's nothing that goes into both 19 and 12. And notice that in general in algebra, we prefer the improper fraction rather than the mixed number 1 7/12. So I'm going to encourage you to just leave them that way. All right, let's compare that to a similar process that we'll use on an algebraic fraction. I'll start by identifying the least common multiple, or LCD. For the 5 and the 3, it's going to be 15 that both of those go into. With the x's and the y's, if I just use the higher power, x to the fourth, since x goes into that, and then y squared. Same reasoning. So there's my LCD. Think of that as your goal. That's what you want on the bottom. So I'll take my first fraction, and I'll ask myself, what do I have to multiply by to turn this into that? Well, I would definitely need a 3. The x to the fourth is fine, but it looks like I need an extra y. So I'm going to have to multiply by 3y. If I multiply by 3y on the bottom, I have to do the same thing on the top. Again, always multiplying by a form of 1, so we don't change the value of our expression. All right, the second fraction, 4 over 3xy squared. Same analysis. To go from 3 to 15 would require a multiplier of 5. X and x to the fourth. I'm going to have to multiply by an x cubed to get that. And the y squared is actually fine. So I'll do the same thing on the top to multiply by that form of 1. My first fraction is now 6y over 15 x to the fourth y squared, common denominator that we very carefully created there. And my second fraction is now 20x cubed. Denominator multiplies out to that same LCD. Now that we have a common denominator, we can combine the two fractions. These aren't like terms on top, so the best I can do is just write them separately. 6y plus 20x cubed over that common denominator. As far as checking to see if that's in lowest terms, I could factor a 2 out of the numerator, but 2 doesn't divide into 15, so that's not going to give me anything. And since these are add-ins, there's nothing I can do with the x's and the y's. So I think I'm just going to go ahead and leave it in that form. All right, we'll look at a few more. So here's just a quick little outline of what happens if you're not given a common denominator. You can read that at your leisure. If it helps you, that's great. But I'm going to dive right into the examples. Here I've got two binomials, two different binomials as denominators. So their LCD is actually going to just have to be the product of both of them. So I take my first fraction and say what I'm missing to get to that LCD is the x minus 5. Plus, my second fraction was 2 over x minus 5. And I do the same kind of analysis. What am I missing to get to this LCD? I'm missing the x plus 3. Always multiplying by the same thing, top and bottom. All right, the first fraction is 6x minus 30. And I'm just going to leave the denominator in factored form. And over here, my numerator becomes 2x plus 6. Again, I'll leave my denominator in its factored form. Now that I've got a common denominator, it's okay to combine my like terms. I'll have 8x minus 24 over the LCD. And by the way, the order that the fraction, or the factors rather, are written in really doesn't matter. So just pick one. Like so. Once again, we'd want to ask ourselves whether there's anything that could be reduced. I know I could factor an 8 out of here, which would give me x minus 3. But I don't quite have that. I have x plus 3. So I don't think that even if I factored, anything would reduce, and therefore I'm going to leave this one just like that. As I look at example 4, the first thing that I notice is that the denominators are not in their factored forms. And if you haven't picked up on it yet, keep in mind, anytime we're working with algebraic fractions, we essentially always want factored form. So let me get that first. Taking out an x makes that x times x minus 2. And for this trinomial, I'll start with x times x to get the x squared, and then a sum of -5 and a product of 6. I'm thinking -2 and -3 would do that. All right, let's identify our LCD. I definitely need the entire first denominator. And then when I come over to the second one, if something's already there, I don't need it again. That x minus 2 is already in the LCD. But the x minus 3 is new. So I'll tack that on. And there's my LCD. All right, my first fraction is actually missing that x minus 3 from its denominator. So I'll go ahead and multiply by the form of 1, x minus 3 over x minus 3. My second fraction is just missing the x. So I'll multiply by x over x. First fraction gives me 4x minus 12 over my common denominator. And the second fraction just gives me a minus 1 times x is x over that LCD. Again, it doesn't matter what order I write the factors in, so I'll just write them the same. 4x minus 1x would be 3x minus 12 over my whole common denominator. Although this factors, I could factor out a 3. That would leave me x minus 4, which wouldn't reduce with anything on the denominator, so I'm going to leave it just like that. All right, couple more. In example 5, we once again have denominators that are not factored, so let's do that first. X squared is x times x. And let's see, a sum of -2 and a product of 1 would be minus 1 minus 1. This one's going to take just a little bit of extra work. It's 2 steps, so let me write it out up here. It's 3 times x squared minus 1. But then I would have to finish factoring by the difference of squares. 3 times x plus 1, x minus 1. All right, common denominator. I'm definitely going to need both of those x minus 1s, since there are 2 of them, but they're in the same fraction. I've got to use them both. Over here, I'm going to need a 3. I'll put that out in front. I'm going to need an x plus 1, but the x minus 1's already in there. So the first fraction is missing the 3 and the x plus 1. So I'll put those both in. For my second fraction, I have everything except for one of the x minus 1s. There's supposed to be 2 and I've only got 1. So I'll put the extra one in. And let's see here. In my numerator, maybe I'll take this in a couple of steps. I would have x minus 2 times 3x plus 3 over the common denominator. Minus 4x minus 4, also over the common denominator. Multiplying out this numerator is going to give me 3x squared plus 3x minus 6x minus 6 over this big, long common denominator. By the way, if you want to write that as x minus 1 squared, that's fine. Just save yourself a tiny bit of writing. Here, I think I'm going to change this to a plus and then distribute the negative 1. So that becomes a negative 4x plus 4. All right, we're almost there. I've got the 3x squared. And let's see, that would be a negative 3x, and a negative 4x over here would be a negative 7x. And negative 6 and positive 4 would be a minus 2. Finally, there we go. All combined. All right, our last example here, number 6. Let's start by getting factored forms. I've got a difference of squares down here. W squared is W times W, and that's going to be a plus 5 and a minus 5. In the denominator, I could factor out a W, and I'd have 5 minus W. Now, there's something going on here before I identify an LCD. We've seen these kinds of things before. W minus 5 and 5 minus W. I really would rather not put both of those into my LCD, even though they really are different. They're not the same factor. What I can do to make them look the same is I could actually multiply this one by negative 1. So here's my little trick here. I'm going to multiply this by negative 1 over negative 1. And I'm going to choose to distribute the negative 1 into the parentheses on the bottom. So that makes my numerator negative 2W. The denominator, that first W is still just a W. Remember, when you multiply, you only multiply once with each factor. So I've chosen to multiply that negative 1 into this factor, not that factor. Inside my parentheses, then, this becomes a positive W, and that becomes a minus 5. And now I've gotten these to match up really well, and I won't have nearly as many terms in my LCD as I would have otherwise. So speaking of the lowest common denominator, my first denominator, W plus 5, W minus 5. And then in my second denominator, I need that W, but the W minus 5 is already there, so I don't need it again. All right, in my first fraction, to match this LCD, the only thing I'm missing is the W. So we'll multiply by the form of 1, W over W. In our second fraction, we are missing the W plus 5. So I will multiply by the form of 1, W plus 5 over W plus 5. I'm going to go ahead and put in a few parentheses here for clarity. So in my first fraction, when I distribute this w, I'll get w squared plus w over the common denominator. Again, it doesn't matter what order I write the factors, I just chose to put the w out in front. And here I'm going to distribute the negative 2w. So negative 2w squared minus 10w. All right, we're almost there now. I'm going to have a negative w squared. I have a common denominator, by the way, so I can combine. So a negative w squared and a negative 9w. All right, a couple of times I've said, hey, when I thought about taking out a common factor, I didn't bother because nothing was going to reduce anyway. Here's an example where it will. If I factor a w out of that numerator, I'll be able to divide it with the w in the denominator. So this time it's going to be worth it. Let's factor out a w. Makes that a negative w minus 9. Make sure you can see that here. And now w divided by w is just 1. So for a final answer, I end up with minus w minus 9 over w minus 5, w plus 5. All right, that brings us to the end of part B.